Hello, hello. Hope we're live. Uh, Let me just check. Do, do, do. Yep, okay, looks good. Uh, yeah, okay. So yeah, we're back again today. We're going to be looking at GCSE Maths. And yeah, I'm just going to go over one of the past papers. Just go through it, work through it together, and then just go through it. So the aim of this, obviously, go through the paper, but also not necessarily just be a mark scheme. We'll probably mess up somewhere. That's natural, but the idea of I go through it and then you see what the thought process is behind the paper, how you should approach the question, what you should look out for, stuff like that to try to maximise your marks essentially, and also revision. And yeah, I believe the first paper is this week, isn't it? This Thursday in a few days. So yeah, we're going over paper one. This is a non-calculator, so this paper will be looking to test your arithmetic and things like that. And yeah, I think that's all to say really. Well, should also say I'm new to this as well. I'm new. Well, I haven't touched maths in ages, years, but also I'm new to streaming, I guess, but to writing on like paper and doing stuff on digitally, like writing like that and stuff. And yeah, I did a stream on the for an A level paper a few days ago. There were some hiccups. Uh, but yeah, we'll get through it together. But yeah, the aim of this is not necessarily just me to give you answers, but to work through stuff. So yeah, obviously any questions or anything like that, just reach out, let me know. Anything in particular you want me to go over, I'll try my best to answer, go over it. But yeah, so I thought the aim of this is to go for a paper, essentially. So I guess I'm going to stop waffling and without further ado, let's move on. So, uh, yeah, so the first question is the fractions. I'll pretty much almost definitely expect a fraction question like this to appear on your paper, the first paper. So yeah, let's get started. So the first of all, work out this mixed fraction. Okay, so obviously when you got a mixed fraction like this, the best thing to do is to firstly convert it into like a mixed fraction, like a fraction with no number in the front. No, an improper fraction. So a mixed fraction is, well, mixed. It has a number and a fraction, so it's mixed. An improper is a fraction on its own. So we want to convert the mixed fraction into an improper, and then it'll make it easier to do calculations with it. Anyway, so 2/7 over 1. Okay. So things with mixed, you need to times the whole number by the denominator and add the numerator. So, 2 1 over 7. Wow, it's going to be 14, right? And then you want to add 1, so that's going to be 15 over 7. Likewise, 1 1 over 4, it's going to be 1 times 4, 4 add 1, which will be 5 over 4. And therefore, what we want to do is essentially add 15 over 7 plus 5 over 4. Okay, there's no clear you could spot it, but there's no clear like common denominator we can get out of this. So the best thing to do is to times all this first fraction by the 4 and the second fraction by the 7. So then it's 7 times 4 is going to be 28. So you're going to want two fractions over 28. So then 15 times 4 is going to be 60. And 5 times 7 is going to be 35. So that's going to be 95 over 28. I believe it didn't say to simplify here. It says it in part B, but in part A, it doesn't expect you to simplify. So it's fine to leave it like this. And yeah, so then part B, it's essentially the same sort of thing, but instead of adding now, we are dividing. Again, the same way here. I spot a mixed fraction. Before anything, let's convert it. You don't have to do this step by step. You can, if you feel confident, obviously, just rush into it like this. It's fine. But okay. One and a fifth is going to be 1 times 5. 5 plus the 1, 6. 6 over 5. And essentially, what we want to do is 6 over 5 divided by 3 over 4. And you should remember KFC here. So keep, flip, change. So you want to keep the first fraction. Flip this, so instead of dividing its times, and then change the fraction, or flip the fraction, I guess, and change the sign, right? I don't know why it's not KCF. I feel that would make more sense. Keep change flip. But okay, you want to flip the second fraction, and then change the sign so it's divided. And then with multiplication, obviously, you can simply times across, no matter what the denominator is. So numerator 6 times 4 is going to be 24. And the numerator is 5 times 3, not 3, that's God. 5 times 3 is 15. But then it asks us to simplify as a mixed number. Okay, so if you convert it back to mixed number, so you need to see how many times the numerator denominator goes into the numerator. So 15 goes into 24 once, so that'd be 1. You keep it. And then you look at the remainder. So then 15, and then how much do we need to get to 24? 9, right? 9 over 15. However, it also says to simplify in simplest form, which says that this isn't simplified. Well, keep the 1. So we can simplify this fraction, can't we? Because what number goes into both of them? 3, right? So that'd be 3 over 5. And that should be your answer there. So yeah, very once you know your fractions, it should be a fairly automated thing to do, right? It should be pretty clear the method to use. Just there should be anything different here, right? And also say these first few questions are for both high and foundation, so this first bit will be applicable for all students. Okay. Uh, but yeah, so obviously, just remember convert the obviously mix it in proper, work out how to do that. And also remember with adding, you have to keep the denominator the same. So the idea is we make both fractions equivalent such that both fractions have the same denominator, which means we can then add them like this. Okay. However, if you're times in, it doesn't matter. You can just times as you expect, right? Times the top numbers and the bottom numbers. And yeah, remember KFC or KCF or however you remember it. But yeah, a bit of work for the first 4 marks. I'm not gonna lie. But yeah, I would also expect, by the way, usually question ones, I would expect mental multiplications, something like 0.34 times, I don't know, 18, or likewise a divide. Okay. I would expect one. Normally they ask you that, but for this paper, that I don't know. This year they decided not to, but usually I would expect that. Okay. Unless it's on the next part of the question. I don't know. Anyway, that's question one. So question two, I need to go out in the chat as well. Hang on. Okay, cool. So question two, in the village, the number of houses and the number of flats in the ratio 7 to 4. The number of flats and number of bungalows in the ratio 8 to 5. There are 50 bungalows in the village. How many houses are there in the village? Okay, so this is a fairly common ratio question, right? They give us basically three quantities, A, B, C, but they split it up. So houses to flats to bungalows. Okay, in general, these papers, you want to split it up and use information bit by bit. Okay, so it says houses to flats. So I'm going to say H to F. It's saying that's 7 to 4. Okay, and then likewise well, let's work with this one. So it says thingy book, the 50 bungalows in the village. How many houses? So you want to get from bungalows to houses, right? Let's work with this first bit then. 7 to 4. So with ratios, what I would say is, um, uh, can make one of them to 1, 2, something, a number. And I think the best way is to divide by 4. So, this is the same ratio as 7 over 4 to 1. But she's telling us, oh, that's a really rubbish one. Uh, for every flat, there were 7 over 4 houses. So one flat, which doesn't look the nicest, but that's fine. Let's see what happens. And we're also given the number of flats to bungalows. You don't have to define the letters, it's fine, by the way. They'll know what you mean. 8 to 5. And likewise, divide by any number, 5, for example, to get 8/5 oh, to 1. That's telling you one bungalow is 8 over 5 flats. Now, if we know one bungalow is this, it says there's 50. So what we do is times by 50, get 50 bungalows. Wow, that's going to be 8 over 5ths times times 50. Oh, hang on. You can do that calculation here. 8 over 5 times 50. So it's like again, it's like fractions again. So I wouldn't do 8 times 50. I think that's a bit much. You should be able to spot that the 50 will cancel the 5 out. So that would be 8 times 10, which should be 80. Okay. I guess you can spot that. Recognize 50 is 10 times 5, and then obviously the 5 cancels out, and then you're left with 8 times 10. Obviously, if you really, really want to, you could do 8 times 50, but I don't recommend it, especially for only 3 marks. I guess it's not the worst thing in the world, right? Do 8 times 5 and then times 10. But in general, try to look for, especially with paper 1, try to look for simplifying stuff um, to make your calculations easier. Anyway, so that's that. So we now know there are 80 flats. Okay. But we need to know how many houses there are, right? Because something houses. But we know, let's get rid of that then, that's the aim. But we know that there are, one flat is 7 over 4 houses. So therefore, to get to 80 flats, we're going to need to times by what? We're going to need times by 80, yes. Which is 7 over 4 times by 80. Again, look for cancellations here. We know that 40 goes into 80 20 times. So that means you'll be left with 7 times 20. And then that's the same as 7 times 2 times 10. So that's 140. So that should be 140 houses, right? Okay. Nice. You can actually make this a bit more condensed as well. Uh, when you have like two related ratios, you can connect them together. So we know H to F. This is an alternative way. If this is the safe way, I like to call it. I don't know. Obviously, it can be a bit longer, but that's one way of doing it. Another way is kind of cut some of it out. So, hey, we know the houses to flats is 74, but we also know that flats to bungalows is 8 to 5. Cool. Okay. Now, actually, we can actually put this all as one ratio by there will always be a common thing, right? In this case, F or flats is in both of them. So what we need to do is to ensure that flats is the same number on both of them. But actually, this actually might be easy because if we instead rewrite this a bit as flats to houses to make it clearer, which means we flip the size, so now it's 47. We actually spot the F is actually this is just a half of this. So to get this, this is also the same as saying 8 to 14. And actually, now we've got the same number. So we can actually combine this together as flats to house to bungalows is going to be 8 to the house, which is 14 to 5. Which now allows us to directly compare houses to bungalows, right? So 14 houses is 5 bungalows. And actually, it says there are 50 bungalows. Yes. So again, you want to times by 10 to get 5 times 10 to 50. And we're going to times this by 10. 140 then houses. Okay. And actually, I think I prefer this. Actually, I think I might explain using this. This is a long-winded way, but it breaks it. That if you're struggling, this is how you'd break it down, right? Line by line. However, I don't know. I recommend this one if I'm going to be honest. If you're a bit more if you're a bit more efficient, if you're a bit more knowledgeable and comfortable with ratios, you can combine ratios like this into one. Um, and it's a quicker, right? So you get 140,000 with 50 bungalows. There you are. And that's another way of doing it. Okay. Do it clean as well. But yeah, that's how you'd approach that sort of question. Ratios. The ratio question's mostly always the same. I'd expect a question like this on your paper. And looks like we're about to get another one. Renee buys 5 kilograms of sweets. She pays £10 for all the sweets. Renee puts all the sweets into bags. She puts yellow yellow. Okay, what's the ask us work out a percentage profit. So a profit is going to be uh no, it doesn't tell you, so you should probably know. Profit's going to be money made or the revenue technically, but from that, not make it too businessy. Money made, so a sales, a profits, not profits, a revenue minus cost, right? That you're going to need to be aware of, I believe. So yeah, so let's have a look. So she buys 5 kilograms of sweets to sport. I can't speak. 5 kilograms of sweets to sell. So buying that would be a cost. So she pays £10 for the sweets. So £10 is probably going to be looking like the cost here. Let's read it forward. She puts all the sweets into bags. She puts 250 grams of sweets into each bag. So what's happening is she's selling each bag, right? Of how many bags she has. Okay, she sells each bag of sweets for 65p. She sells all the bags of sweets. Cool. Okay. So her cost is £10. Uh, okay, but here it's telling us the information per bag. So I think what we're gonna need to work out is how many bags she sold. But it tells us some information here. 5 kilograms of sweets to sell. Okay. But we also know she pays £10 for the sweets. So I guess. Well, does it give us any cost here? Does it? Not no. Puts all the sweets in the bag. She puts 250. Ah, okay. 250 grams of sweets into each bag. But we know she bought 5 kilograms of it. So how many bags used? Well, that's going to be 5 kilograms over 250 grams. Now the units are essential here because you need to make sure they're the same. So 5 kilograms is going to be 5,000 grams over 250 grams. Because you must remember 1 kilogram is 1,000 grams. And actually, then we can start cancelling. So we can get rid of the 0 here. To get 500 over 25. Which I believe should imply it should be a whole number, right? So how many? 25 goes into 100 4 times, and then it goes into 500 another 5. So it should be 20, right? You can check this because 500 is wow 25. Oh, not 25. 25 times 4 is 100. Okay, and then we want to times by 5 afterwards. So 25 times 4 times 5, which is 20, right? So that's where the 20 comes from there. But yeah, but as this paper, as I said, this paper really does assess your arithmetic. So that's sort of calculation you are expected to make, unfortunately, if not your strong suit. But yeah, anyway, that's 20. So there are 20 bags used. So that'll be our first point. Um, okay, but now we know how many bags to use, we can work out the cost per bag, can't we? I think that will help. Uh, and that's going to be, well, we know there are 20 bags in total. Uh, and we know she pays 10 in total, right? So £10. And that's distributed over 20 bags, right? That's shared amongst 20. But that's going to be a half, right? So it's going to be 0.50 pence. Cool. So the cost of the bag is 50p. Now it also tells us she sells its bag, so the money per bag is going to be 65p. So therefore, profit profit per bag is going to be 63 minus 50, which is 13p. Oh no, mate, what? 65. Where did I get 63 from? Uh, 65, sorry. Ugh. That's 15p. So then the profit, the percentage profit, so the percentage profit is essentially going to tell us, well, it's a percentage of how much of the money she made is profit. So that's going to be uh, 15 over 65. So that's going to be the profit she made out of the total amount she got from the bag. Okay, so how much of the money she gets from each bag is going towards the profit. And then that's going to be times by 100 because it's a percentage. So now we need to work out this bit. So uh, let's simplify it a little bit first. Oh dear. Okay, well, directly we don't know what number this is, but we know it goes into five. Five goes into each side, right? So it's three over. Then that might help us. Uh, 13, right? Yes, I believe. Times 100. Hmm. Hmm. Interesting. The idea with ooh, I must admit, I don't think. If my number's right. I don't spot. I feel like it should be out of 12, not 13. Uh, 10, 11. No. I must have, my numbers must be off somewhere. Let's check. 5,000, 500 over 25. That should be right. That's 20 because we did check that. So it's 20 bags, and so the cost per bag. So we know it costs £10 per total in total. So out of 20 bags, 10 over 20 is a half. So that'd be 50p. So then it tells us the money per bag is 65p because she sells it for 25p for each bag. Uh, so the profit per bag. Oh, oh no, never mind, never mind. Uh, so then the profit be money she sold it for, the money she got from it minus the cost to make it. She's 65 over 50p. That's 15, I believe. So then the profit be 15. Uh, I believe it's 65. Would it be out of 50? Would it? No, that wouldn't make sense. No, that wouldn't make sense at all. 15 over 65 times 100. Uh, 15 doesn't go to 65. I don't think. Nah, 5 does. So then that's 3 out of. Surely they don't expect you to use long division here. Surely not. Because I can't spot a way to simplify. I don't think I can. This won't get you a nice number. So I don't. Hmm. Nah, it has to simplify nicely. I feel like. No, that's 13. 5 goes into 13. No, 5 goes into 65 13 times, don't it? Yes. Hmm. Interesting. So then that would obviously go to 300 out of 13, but that's not. Hmm. I think something's not off. Something's not right here. I guess let's just try long division. I don't know. Maybe it'll get somewhere. I don't know. So 3 goes no. 1 no times. That's no. 3 goes into 13 4 times with a remainder of 1. 3 goes uh, into 10. 3 times remainder of 1. So it's a recurring decimal. There's something not right here. Hmm. And this is a good strategy, by the way, if you're stuck in exams. Something's not adding up. Check your working. Uh, Maybe I just misread a number. Probably. That's 5 kilograms, right? To sell, she buys them sweets. So that's the cost. So the bags used 5 kilograms, and she puts 250 of sweets into each bag. So that means she'd have 20 bags to use 5 kilograms of it, right? And then the cost per bag would be. I can't believe it's stuck. I can't believe it. £10. So the cost, yeah, so she cost £10 for all of it, and then per bag there's 20. So that'd be 10 over 20, right? Which should be a half. Which should be 50p, right? Half of a pound. Okay. Then it tells us the money per bag is 65p. Because she sells each bag of sweets for 65p here. Yeah, she sells all the bags of sweets. Okay. Work out percentage profit. Um, yeah, so her profit we worked out is 65. So the money she got minus the cost of it, 65 minus 50, which should be 15. So then the profit is 15 out of the money she got out of it, which is 65. And that should simplify to. Yeah, yeah, something got wrong. I know. I just checked on the calculator. Obviously, I know you're not allowed one. You do get a nasty decimal, so yeah, I need to check the mark scheme for this one. I don't know. I must have done. I don't know. Uh, God, I can't believe it. On this quite. What is going on here? Uh, oh, so it says it's out of 50, not 65. That makes no sense, though. A profit out of the cost. Is that how it's measured? So profit is a proportion of the cost. I thought it was a proportion of the sales of it. Okay, so I lost. Okay, so I didn't understand the question because I didn't know what profit was. I don't think that's fair, but I don't know. Yeah, Seven House was right. It's just not understanding the profit. God, good job I didn't get into business then. So apparently, it's not out of the money you get in total, it's out of the profit, which probably makes it a lot nice. Yeah, so then it goes to 3/10. Okay, so 15/50. Well, it goes into five into each of them. Five goes to 15 three times and into 50 10 times. Well, we could immediately spot that should be 30%. Okay. And that should be the answer. That is extremely silly, though. I'm not gonna. I really thought profit. I'm gonna look this up now. Actually, while I'm here, I thought profit was out of the revenue, right? Uh, profit. It'd be like a profit margin, wouldn't it? The amount by which revenue from sales exceeds cost in business. What's the definition? Yeah, so net profit margin or the profit margin is revenue minus cost. So the money you get is the revenue over revenue, not the cost of it. How does that make any sense then? Yeah, all the formula. Yeah, every formula I'm saying is the profit is defined by obviously the profit. So what we calculated the revenue minus cost over revenue. But this for mark scheme is saying it's over the cost of it instead of the revenue you make for the bags. I'm not too sure about that one. I mean, if it was just me and everything else said it was out of cost, I'd hold my hands up, but I'm not entirely sure if that's how you calculate percentage profit. Well, I guess percentage profit might be. Let me look into this. Hmm. Okay. Okay. There seems to be some variation. Uh, okay. Some seems to define it as obviously the profit over the cost of it. I don't know. I've never seen that before. I don't know. That's new to me. So I guess my recommendation is if you see anything about profit, check both your answers. I don't know. But do cost first, apparently. Then do your profit over the cost over rather than the revenue, the money you get in total. See what. Hopefully the answer should be sensible, but I don't know. That's new to me. That is really new to me. I've never seen profit done like that before, but hey, I guess new to everything. But yeah, that's the procedure essentially with that question. Okay, okay. So my math wasn't wrong, really. It was, I don't know, the interpretation of profit. I don't know. Hopefully this one should be a bit better. Okay. So a cycle race across America is a very specific amount of miles in length, that number. He knows his average speed in the other races is that. for the next race in the cycle. Okay, there's different situations going on here. They're talking about previous races and the next race, so I think it might be good actually to um, split it into two, right? So, and that's a good thing with these distance time things. Usually they give you two different situations, and you need to find the missing information. And you see what I mean in a minute. Uh, so we've got distance, we've got speed, and we've got time. So obviously you should know distance is speed times time, or this triangle here. No, distance, speed, time. Yeah, speed, time. This lovely triangle here. So you want your distance, you times speed times time. You want your time, you do distance divided by your speed, and your speed, you be do distance divided by time. Okay, so we know in this next race, the distance is going to be 3069.25 miles. Not to be confused, actually, I'll write it here. Not to be confused with meters. Okay. He knows his average speed in his previous race is the speed. Distance we don't know yet. His speed is 15.12 mph. For the next race, he will cycle for 8 hours a day. 8 hours per day. Okay. Yeah. So actually, I don't think you need to bother with it. I think you assume here his speed will be the same. Okay, it'll keep the same pace. So that'll be 15.2 for his speed. No, hang on. Yeah, I think you just assume it's the same. That's MPH. Uh, no, actually, it's supposed to. The time is 8 hours per day here because it's asking us how many days to complete the race. Okay, so let's work. So we want the time as a whole, right? Let's ignore that. Turns out we don't need that. But it's always good to jot information like that down. If you don't need any other information, it's fine. Just play it safe. So how many days? So we can work out how many hours overall by doing distance over time. So the time will be distance over speed, right? So that'd be 3069.25 over 15.12. Okay, the numbers are horrific. However, bear in mind it says estimate here, which means you have to pick the sensible rounded versions. So I think here to make the calculation nice for us, I think it makes sense if we did this to 3000 and this to 15, which you could perhaps argue you could round up to 20. Maybe you could. But does this what the idea of estimating when you round your numbers, it should be fairly simple to work out. Um, yep. Tell you what, I think it's best to do 20 here. I think 15. Uh, hmm. Does I don't. Yeah, so that would go to 300 over 2, which obviously be 150 hours. in total, but it tells us days then. Uh, that's going to be 150 hours in total, but we know it takes 8 per day. So you want to do 150 divided by 8. Um, Again, we might need to estimate. No, no, we shouldn't need to estimate that. Let's have a look. So, okay, so okay, well, actually, I think let's write this as a fraction, and you'll see why. Because now we can easily simplify it. So we know uh, 2 goes into both of them. So 150 over 75. Yes, that doesn't have it simplified. That I don't think it's simplified anymore. Can't do. Okay, so how roughly we know that 80 is 4 times 20, so 76 is 4 times 19. So it's going to be 18.75 days. Well, actually, then if we round up, that's going to be 19 because he's not going to finish on 18 days. It's going to take a bit longer. So if we round it up, it should be 19, I believe. Okay. Let me check that's right. I'm not giving you any false information there. Du- du- du. Uh, just says estimated value. Um, I don't know. Just it's weirdly doesn't give a definitive value. So I guess it'd be 19, but I think 19 would be okay there. Make sure it indicates rounded, but I don't know. It doesn't give a concrete answer. Anyway, so 1 then trains for the race. The average speed it increases. It's now. So how does this affect your answer to part A? Okay, so they give you the number here. Well, we know the new time then would be. Well, it doesn't, does it? Because if you remember, we rounded 15 up to 20. So, no effect because 16.27 would still round up to 20 mph. Um, like with 15.12 miles per hour. Okay, so see here, when we did overall time, we divided by the old speed, which is 15.12. We rounded out to 20. We would also do the same here. So 16 would go to 20, so it would have no effect. But yeah, that's what the mark scheme says. It doesn't affect the answer because I'd still round down to 15 or up to 20. Yes, so here we'd round up to 20 like we did before. Cool. So that's that. Here we go. Solid square base pyramids. I'm not a big fan of these. For the main reason that it's hard to explain questions like this that are so geometric and visual. But let's go through a bit. So it's told us basically this shape here, and it's a square base pyramid. So it's a pyramid full of triangles, and obviously the base is a square. So it's telling us to draw an accurate, which means we're going to need to measure. We actually need to get the dimensions right. So this length. Now, actually, this is a centimeter grid, so each line will be 1 centimeter. Now, this is going to be awkward because I'm on a pen. I'm on like a digital pen, and it's really hard to draw accurate lines. I don't know how to do it yet. I don't know if you can, but for me, I don't know. I'm gonna have to be rough with it. Well, anyway, so it says a front elevation. So when you're doing this sort of thing, especially with 3D shapes, it's best to realize that you got a bunch of 2D shapes because that's what 3D shape is essentially. It's a composition of all different types of 2D shapes. So here we've got triangles and we've got square. So that's what's going on here. So this will help because if we look at the front view, we know we're basically staring at a triangle here essentially. We wouldn't see like the side of it if we're looking at the front. We wouldn't see the side. The most we'll see is this edge here, this line edge here. Likewise with this, and we wouldn't see the back of it, and obviously we wouldn't see the base. The only thing we would see is this little triangle here. Very messy one. Uh, A, B, and V. And the length of this would be 6. And it tells us uh, um, we know it's going to have a straight height of 4. Now, that's not the slanted height. That's the height from literally the base here all the way up to the top, I believe. Yeah, because this 5 here is slanted. Uh, so I believe that should be 4. Uh, um, but we also know the top here is the midpoint of down here, the midpoint of the triangle. So what this means is this length here is going to be 4. Because bear in mind, this is a straight height here. This is straight, like here, from top to bottom. This is not a slanted height. We wouldn't see the slanted bit with the front view. We would just see a triangle, right? So the height would be 4, and the base would be 6. But we also know because this is the midpoint, it'd be split into 3 centimeters and another 3, which would mean which would help us draw it. Sorry. So yes, let's draw it then. Let's use these measurements then. So essentially, we've got to put this onto here. Okay, so if let's put this in the middle then, right? The 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 tip. Oh God. The vertex up here. We know we have to go 4 down to reach the base. Uh, but we know that's the midpoint. So if we go 3 across, that'll be our first one, our first edge. No, that's 2 across. Bloody hell. 1, 2, 3. There we are. But we also know 1, 2, 3 here. So that should be six, right? Six boxes. One, two, three, four, five, six. That should be four down. One, two, three, four. And yeah, so then obviously remember I don't have a ruler or anything to straighten this, so it's going to be messy. But make sure you connect this with a ruler with each point. So then it would look, well, it would have looked something like this because it's really bent. But that's the idea. But obviously the lines should be straight. Okay. Um. But that's what it should look like. I believe anyway. If I'm wrong, obviously correct me. But that should be right. Yeah, the mark scheme says isosceles triangle, space of six, height of four. Yeah, so the base six, height is four. Cool, yeah. Then it says work out the total surface area of the pyramid. Okay, so with surface area, about like I said, 3D shapes are just compositions of a bunch of 2D ones. So a triangle and a square. So the surface area. So imagine if we hold this shape in the air, in the middle of the air. So every side is exposed. So the square base and all these triangle sides. We want to work out the area that we can see, not the area inside, that's the volume, but the area of the surface, right? How much surface space there is, which is the individual areas of all these little shapes and sides here. Okay, so what's the area of a triangle? Just look here where it should be half times base times height. So the base of any given one is 6. And also the the perpendicular height. Okay. Now this is an important distinction to make with this. The height here is not 4 because see here, this is not connected to the triangle. It's not reaching the triangle. It's hitting the base of the square. However, this line is so this line is slanted, but it's hitting from the top of the triangle, like here, to the midpoint. So that would ensure that this gives two 90-degree angles on the side of it, like here. So this is the perpendicular height because it obviously crosses the base, but this does not cross the base of the triangle. So that 4 centimeters is not the height here; it's 5. So the height we have here is 5. So then, therefore, the area of I should write that here. The area of a triangle of one triangle is going to be 4 times a half times the base, which is 6 times 5. Now 4 times 2 goes to 2. And then times 6 times 5 is 30, which is 60 centimeters squares. Okay, so that's the area of one. Oh God, what's going on now? That's the area of. Oh God, what's that? The area of one triangle. But it's that's obviously the total surface. So how many triangles are there? One here, ABV. There's two, three, four. So obviously you got this triangle here and the back side opposite. So VDC. Uh, you have you obviously have this one on the side and obviously the one fate opposite against it again. So the area of the triangles, you're gonna time by 4 because there's 4 lots of them. Um, so therefore, area of 4 triangles is 60 times 4, which is 240. And that's the area of the triangles, but we also have this square base here that we would see. If you imagine if we look underneath it in the air, we would see the square bit as well that's exposed. Well, it's just a square, so we know that one side length is 6, so all of them have to be 6. So therefore, the area of the square will just be 6 squared, 6 times 6. Um, 6 times 6, 36. So therefore, total surface area is just going to be combining them all together. 30, oh God, 36. Oh, what's going on here? 36 plus 240. That's going to be 276, I believe. Oh, hang on. Oh, hang on. I messed up. Uh, you know what? Yeah. So, and when when I did one triangle, I actually did four on accident. So I've quadrupled my answer when I shouldn't have. This is where you check your answer here. So the area of one triangle is just a half times 6 times 1. 6 is the base and 5 is the perpendicular height. That will be 15 centimeters squared. So then to get four of them, obviously, then you do 15 times 4 to get 60, not 240. And then that's 36. So then you want to do 36 times plus 60 is 96. I just didn't order my workings there. Again, you have to be careful with that type of stuff. But yeah, I went too far ahead, thinking too far ahead. I was doing area one and I accidentally did four in the same one. Anyway, but yeah, that's the idea of that. That is the answer there. Just checked it. And then we on to this one. A fun little question. It says a pattern is made from four identical squares. More squares now. The sides are parallel to the axis. Okay. Point A is that, point B is that, and point C is marked on the diagram. Find coordinates of C. Okay, so obviously the fact it's a square is going to do a lot of heavy lifting here. So we know if we use A and B coordinates, we know that the total span on the x-axis is going to be well, the change in x coordinate, right? So it's going to be 38 minus 6, which is 32. So that's 32. Likewise, the change in the y is going to be well, 36 minus 7, which is going to be 29. Now that's important because what we can do then is we can work out the length of one square. So might make that a bit clearer actually. Starts there. Yeah, so changing y by 36 minus 7, 29. And then changing x 38 to 32. Make sure you see, always double check your workings periodic as you go through it. But anyway, so we know, let's just use this for example. We know that one, two, three, four sides has to be 32. Therefore, one side is 32 over 4, which is 8. There's no units, so just leave it as 8. And the squares, so that means every single side here is going to be 8, 8, 8, 8, 8, 8, 8. Okay, yeah. 1, 2. Okay, but actually, if you notice, when we go up here, it's not exactly 4 whole lengths because you have one length here, 2 lengths then up here. But here, this circle is kind of wedged in, so it's not the full length. And then obviously go another length here. So what we can do is, we know that this is going to be 8 in total. Oh, but we can also work out this little gap here, this little step, because we know that it has to be 32 in total, because there's 4 sides. Uh, um, how do I wanna write this down? Want to work out this gap here. Uh, let's call this length x. Then say. Uh, so we know that there's 1, 2, x, and then 3. 3 sides and an x. And each side is 8 plus x. We know, as we've seen here, it's 29. That's to change in the y values. So then we can solve for the x. So we know that this is 24. Therefore, x is going to be 5. So this distance here has to be 5, which means because the total is 8, that means this has to be 3. This little gap here between here and C. So, uh, therefore the y coordinate of C, well, that's going to be 8 and 8, because we go 2 sides up. 1, 8, and then an 8. But then we go down by 3, so it's going to be minus 3. So 16 minus 3, it's going to be 13. Okay, cool. So then to find the x-coordinate, well, the x-coordinate is simply going to be an 8 length here and an 8 there. So the x-coordinate is going to be 16. So the answer should be 16 and 13. Hang on. I just checked. Something's wrong here. What have I done wrong? Um, um, no, 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 no. That's not the x coordinate. No. That is how much. Okay, what this number is giving you here for the y coordinates, how far it's gone up from A. That's not the y coordinate because we've got to add the 7, right? 13 adds 7, which is 20. Likewise with x, then we add the x coordinate plus 6. That should be 22. And that is your answer there. See, that got me there. That did, I'm not gonna lie. But yeah, see, those are the pitfalls you got to watch out for, you know. And then obviously you'd want to add 7. So what we did here is we went from A to C, but obviously you need to include the original coordinate there because obviously we're working at coordinates. So you bear in mind, be careful of that. Okay. Question 7. Shape T is reflected in X is -1, so it's a good idea, I reckon, to draw these lines. You can tell I've not done this in ages as well. Like I've not done maths in years. I think I'm done okay, but a few slip ups, which is natural if you don't practice papers. This is why I always say the best thing with maths is to practice, practice, practice. Or else, like me, like just said, you'll make silly mistakes. Um, yeah, if you continuously refine, work on problems, past papers, and then solve them, spot where you go wrong or any hiccups you make, eventually you should iron them out. But when you get rusty like me, which is why you should practice, then yeah, errors happen. Good learning experience though. Anyway, so y is -2 here. Very, very horrible line. There you go. Obviously, I'm not got a ruler or anything. So it says shape T is reflected in x is -1, which is here. So where's x -1? It'd be this line here to give r. So it's a good idea to reflect it first of all. 1, 2 coordinates there. That's the new coordinate. Here, 1, 2, 3, 1, 2, 3. And then that's just going to be 2 across, so it's going to be there. If you draw this triangle, oh, very badly though. There you go. That should be R. And then it says R is reflected into this line here. So here it's uh, 1, 2, 3, 1, 2, 3. Reflect this one again. That'll just be there. And then here it should be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that should be S. Now, what it's saying here is how do we get directly from T to S with no middle? Now, this can be a bit awkward to spot, but it does look like a rotation because, first of all, it can't just be a translation because it flips here. Uh, it's very tricky to, well, I don't think you can just find a vector to translate it directly here. It's, it's pretty hard. So, um, a rotation makes the most sense here because it'll rotate the position of the shape, right? Well, can't be an enlargement because the shape isn't changing any area. Um, what else have we got? So, and it can't be reflection either. Um, because I guess if you just stare at it, it'd be pretty tricky to find a single line that nicely reflects it like this. So I reckon it's going to be a rotation. It won't be about the origin because this is further away from the origin than this. So how you would tackle this is you'd use tracing paper. I don't have tracing paper, unfortunately. Te- you'd know if you just imagine it. Again, this is why it's hard to explain these other questions without being there physically. You know you want to put the point of rotation to be like here. Uh, and then what? One, two, you're three across. So you rotate that, you're about uh, you're about three across. So I think that might be the point of rotation. I'm not. It's pretty hard to see, but yeah. So the point of rotation is somewhere here. This is where you need tracing paper, but I'd say it's rotation. Okay, and usually with these questions, normally it's 90, 180, 270, or 270 degrees. 90 would put the triangle to be like that. Can't be. So then 280 would then move it to here and then in here. So it's going to be 180. And normally you'd specify it's clockwise or anti-clockwise, but obviously 180 and clockwise could be exactly the same as anti-clockwise. So it doesn't really matter in this instance. Then you need to see say the point. I reckon, I don't know, it seems to be about -2, -2. Again, that is not for sure. What does it say? Um, oh, it says -1, -2. Okay. Okay, there you go. So if you use tracing paper around this area, eventually you spot that this here, that would be the center of rotation. Um, but yeah, see, I was quite close just by visualizing it, but you need to give the exact point, and that you'd get for using tracing paper and testing around here until eventually you map it to exactly here. And that's how you go about it. If you describe with these translation questions, you want to look out for if it's a translation, reflection in a line, or a rotation. It's very easy to spot if it's an enlargement because obviously the shape will change area. If it doesn't, then it can't be enlargement. Um, Obviously, you could argue enlargement with negative scale factor, but that's just reflecting 180. So if you say negative scale factor, that is identical to saying it's reflecting in 180 because that's what it is. That's what it's doing. You're changing the direction, right? So it would be 180. So you could argue it's a negative scale factor, and it does say that in the mark scheme, enlargement with scale factor at -1 in the same point. So they're the same thing, but it's rotation here. So those are the three to look out for. With any sort of like transformation questions. As for rotation, you need to say it is a rotation. You need to say the angle if it's anti-clockwise or clockwise, and the point of rotate. There's a lot you need to look out for here, but for 2 marks, it's quite nasty for 2 marks actually. You got to do all that work. But yeah, that's how you'd go about that. Tracing paper with your friend there. Okay, one question eight. God, God, I think I need to plug my charger in. Okay, there we are. Okay, one question eight now. So the perimeter of a right angle triangle is 72 degrees. 72 degrees. I don't know what I'm smoking. I really don't. Centimeters. The length of its side is given as a ratio. Oh, hang on. Oh, there we go. So obviously, I think it's a good idea to draw the shape of what we're looking at. So right angle, 72. So the lengths are 3, 4, 5. Obviously, you should know that the largest one is going to be the hypotenuse. So that's going to be 5. Now, I think you might be okay with this question. Just leave it as 5. However, technically, it's been scaled. You scale it by a multiplier, which we can call x. So actually, so this tells us the simplified ratio, but this doesn't necessarily tell us what the exact lengths are. To get the exact length, we're going to need to times by some number to get it to the actual length. So say if the lengths were actually 10 and 6, hang on, 8. Well, actually, it's still in the ratio because it simplifies to that. But that's not but this is the exact measurements. But then our multiplier would be 2. Um, so yes, when something to bear in mind here, 5x. But you might be okay, but things will cancel. But technically, that should be 5x, and then the other two sides are 3 to 4. It doesn't really matter. 3x, 4x. And yeah, so those are our lengths. The x makes sure that these are the actual sizes of the length. Uh, but yeah, so it says the perimeter then is 72. Well, actually, that tells us what x is because we know that 5x plus 3x plus 4x is 72. And then it's just simplifying, solving the linear equation. So 5 plus 3 plus 4 collect like terms here. When you're collecting like terms, just add the coefficients. 5 plus 4 plus 3 is 12. And so therefore the multiplier x will be 72 divided by 12, which is does the 12 go to 12? 12 go to 72. 1, 2, 3, 4. Yes, it does 6. Exactly 6. Lovely jubbly. So therefore we know what the actual sides are now. So we know that sides are 3 times 6, which is 18. 6 times 4, which is 24. And then 5 times 6, which is 30, not 50. Got confused. I had 5 on my mind there, so I wrote 5. No, 30. So these are the actual sides. And so the area is obviously like we saw before, half times base times height. Now the base here is 4x, which is 24, and the height is 3x, which is 18. And so let's simplify it a little bit. So that's going to be 24 times 9. I think it's the best way to do it. Okay, which goes to now you could work that in your head. I'm just going to give a quick demonstration. Stuff like this, if you need to do it mentally, but you can't really get there. So just do long multiplication. Should be a quick one. 4 times 9, which is 36. So 6, carry the 3. 9 times 2 is 18. Add the 3, 21. So 1 and 2. So it's telling you it should be 216. And that'll be in centimeters squared. So that's a good tip. If you the numbers are a bit too large or awkward to work with, don't be afraid to use a quick long multiplication or division here or there. So yeah, you can double check your answers as well. So 24 times 9, 20 times 9? Well, that's going to be 180. And then 4 times 9 is 36. 36 add 180. Well, that's going to get you 216. Lovely jubbly. So you know you've done it right. Okay. So that's that. So the key idea with this question is to recognise that ratio is not the same as the actual amounts. We have to make sure that the actual sides are the ratio 3x to 4x to 5x, not just 3, 4, 5. It simplifies to 3, 4, 5 because we can just cancel the x. We can divide by x. That would be the simplified ratio, but that's not the same as the actual lengths and the actual amounts. Okay. Oh, I love these questions. 36 to a half. You should recognise anything to a half is simply just a square root, which root 36 is 6. 23 to the 0, anything to the 0 is just going to be 1. You can kind of, I guess, sketch this because we could say that 23 to the 0 is the same as saying 23 to any power n over the same power n. Well, actually, these two are, and then if you use division law, that's the same as saying 23 n minus n, which is 23 to the 0. So this is identical to this. But actually, if you divide two numbers that are the same, you get 1. So that's where that comes from. Okay. I should have left that there actually. But anyway, that's the reasoning behind that law there, index law. And then we got this hefty one, 27 minus 2/3. Always break it down with this. So, firstly, you got to deal with the negative. Always deal with the negative first. So that's telling you when you have a negative, you take the reciprocal. So that's going to be 1 over 27, 2/3. And then you deal with the denominator. So that's saying if you're 1 over 3, uh, that's going to be the cube root of 1 over 27 squared. Now, actually, remember the third law, root a over b, you can distribute it like this. So split it up into numerator and denominator. And yeah, so we get cube root of 1, which is just going to be 1. And then the cube root of 7, which is going to be 3. 3 cubed is 27. And that'd be squared. And then likewise, 1 squared, which is 1. And then 3 squared, which is going to be 9. So that should be your final answer there. Okay, let's move on. Box plots, cool. Quite a straightforward one, this one. It gives you all the information here. So you just need to know what a box plot looks like. So let's plot the information here. So the least height is 133. So you need to work out what each square represents. So 133, there's 10 squares. So that means one square is simply going to be 1 centimetre, right? So 133, want to go 3 squares over. It's really hard to see on the computer. So it's going to be here, right? Be really accurate here. Obviously, use a ruler, absolutely. But obviously, I don't have one. It's a bit awkward. But that's roughly where it's going to be. In fact, I'll try and do it a bit better. 1, 2. There we go. I don't know, as best as I can do here. That's the least height, but then it connects to the lower quartile. That's 145. That's going to be here. Let's connect this. Oh, in the middle. There you go. And then we go to the median, which is 151. And then, and bear in mind here, oh God, then it's a box. And then the upper quartile next to 157. It should be there. Yeah. Okay. So complete the box. And then obviously plot this again. So the greatest height, which is the maximum, 170. and then you complete the box like that. So I recommend plot all the information first. So plot your least amount, plot your lower quartile, your upper quartile, your median, your upper, and then connect them, and then draw the box plot as so. So you should always have min, then your goes to lower quartile, draw box, median, upper quartile, and then your max. That's how it should look like. So that should be the box plot. And then it says work out an estimate for the number of these girls with a height between 133 and 157. Those are specific numbers there. So 133 is your your minimum, and 157 is your upper quartile, actually. Now you need to know the key property. Upper quartile is the is 75% of the bottom of the data, or 75% of the total, I guess. So this is the bottom, this is the lowest value. Then lower quartile is the bottom 25%. And then the median is 50%. And then the upper quartile is the bottom 75%. Okay, so actually should be a bit more specific here. The bottom 75% of the total amount, how many people there are. Okay, so and it indeed is just 75% of the total amount. Okay, but it also tells us that there are 80 girls in total. So number of girls here between 133 and 157, but that encompasses the bottom 75%. So that's going to be 75% uh of the of 80, right? Now 75% is actually 3/4 of 80, or 0.75. So again, it's just timed in a fraction here. So 80, we know that cancels with the 4. So that 80 divided by 4 is 20. So that's going to be 20 times 3, which should be 60. And that's where it is. And yeah, that should be the answer. Okay. Circle theorem, circle theorem, circle theorems. I've not done circle theorems in ages. Okay. Okay, so we have some information here. We have AB a point, center O. BC is the tangent here to the circle. It might help if perhaps to extend it, but we'll leave it there for now. AOC is a straight line. ABO is X. So this angle here is X. Find the size of angle ACB. We'll call that Y. ACB in terms of X. Give answers to before, give reason for each stage. So it's a circle theorem question, immediately you should spot. So with these questions, I guess the best strategy is to just not necessarily just try and work out all the information you've got and see what you can do with it. So we know BC is a tangent. Okay. Okay, so that might potentially mean we invoke the fact that the tangent and the radius are perpendicular. Just think about the circle theorems that we know. So just to jot them down, got alternate segment, We've got angle at center and circumference. We have uh, we have angle in a semicircle, don't we? Uh, we have a cyclic quadrilateral, but that won't be needed. Tangent and radius, or tangent to a circle, I guess. Okay. Well, we do. So what do we have? We don't really have any segments, really. So that rules out that's initially. And got a center and circumference. Well, we have something here, but it's only one line. So that won't be helpful at the moment, I don't think. Angle in a semicircle. Um, no, because there's only two lines here. If it was in a semicircle, essentially, you put a semicircle is, if we plot the line here, if it's a triangle formed in like in the semicircle, so half of the circle, where obviously what the one of the sides is the diameter of the circle. So it's essentially a triangle in the semicircle with one of the sides its diameter, and then the tangent. Well, the uses phrasing, so obviously we're going to have to invoke the tangent of the circle. So what that's telling us is, and because there's only one tangent, we're going to need to, let's get rid of this to make it clearer. We're going to need to form a radius, aren't we? I think that's going to be the step here. And actually, this is going to be 90. So this is what I mean about using the information you have. Uh, and because we know this is x, this is going to be x minus 90 here. This little angle here, ABO. Okay. Uh, okay, so what can we work out next? So we know we have an expression for this angle here and this angle. Uh, Again, now let's stare back to what we have here. Again, we haven't created any segments, so not alternative. And got a center circumference. Interesting. Well, uh, I don't think so yet. I'm thinking perhaps we could maybe do something at this angle here. Uh, but then we're going to need an angle at the center, which I don't think we can do just yet. Because bear in mind, when you use the center theorem, you're going to need a shape that looks like this. So this is how you apply it. So this angle here, and then this is the center angle. That's where you'd use that theorem, but it's not really clear. This isn't really the shape we got at the moment. Uh, okay, so then let's just keep staring at it. Okay, well, we know this side, don't we? Know this angle, right? In terms of y. Um, BOC. So angle BOC, that's going to be 180 minus 90 minus y. That's going to be 90 minus y. Because of the angle in the triangle, angles in a triangle sum 280. And I should probably also write down that we know that angle, by the way, this side means angle, because obviously it's shown an angle there. And then also angle, just to write this down as well, OBC is 90, as tangent and radius are perpendicular. Cool. So now we know that side in terms of y. We also know this side because it's 180. So this angle here, that one here, and look, it's on line. So that's going to be angle uh, AOB. Well, again, that's going to be 180 minus angle BOC, which would work out to be 90 minus y, which is going to be 90 plus y. And that's going to be because angles on a line sum 280. Cool. Uh, so we worked quite a lot of stuff out here. So we've got B. So we've got this angle in terms of x, this in terms of y, but we don't know anything about this angle, except we do. We know because this is a big triangle here, this angle here, well, we know it's a triangle, this angle x, and this angle y. So we also know the angle ABC, is it? No, BAC. Okay. Uh, well, that's going to be 180 minus x minus y, and we can just leave it there. As, again, angles in a triangle. Sum two. Oh God, what am I doing here? Sum 280. Okay, so actually, we now have some information to piece together what we have. So we know every angle in terms of x or y. That's great. So we know that this angle triangle here, let's draw it here, ABO. We know this is going to be 90 minus x. We know that this is uh, uh, d- 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 we know that's 90 plus y. And we know that that's 180 minus x minus y. Um, Why do I feel like stuff's going to cancel though? I don't. Let's see what happens. Therefore, we know that 180 has to equal 180 minus x minus y. That's BAC. Um, that's this angle here, plus this angle here, AOB, which we worked out to be 90 plus y. Plus this angle here, this x minus 90 ABO. Um, uh, no, let's simplify it. So, the x, oh, this is what I didn't want to happen. X's cancel out. And we solve it. Hang on, that can't be right. We find a value for y directly. But where have we gone wrong? That should be a try. That's 90. If that's y, that's going to be 180 minus 90 minus, that's 90 minus y. Uh, Hang on, we messed up here somewhere. Um, so BOC, so that's y, that's 90. If this is the radius we defined it to be. So this creates two separate triangles, ABO, AOB, ABO, and BCO. So if this angle's y, we know that this is 90 because this is the radius, tangent and perpendicular. So therefore we know this is 180 minus 90, which is 90 minus y. We also know this whole angle here is x, so that's going to be, this bit here is going to be x minus 90. Um, so therefore this one, then this angle, it's going to be 180 minus 90 minus y. Uh, so that should be 90, no, plus y, sorry. Yeah, which is plus what? Oh god. 180 minus this angle here, so that should be plus y, right? And therefore this angle here, well, this is two triangles. This is x here, angle ABI. No, ABO. I didn't read the question. Naughty. ABO, not ABC. ABO, this angle's X here. Yeah, again, I jumped ahead there. So I'm going to need to reconstruct the question a little bit. So let's reshuffle this. So again, keep the radius there. That's going to be 90. This is X now. So that means this angle, again, is going to be 90 minus Y, as usual. That is X. Well, that's going to be 90 plus Y. So a lot of this should stay the same. OBC is 100 is 90. BOC is 90 minus Y. AOB, that's going to be 90 plus Y. Yeah, yeah. And therefore, BAC is going to be 90 plus X, 180 minus 90 plus X. No, hang on. ABC. Hang on, what have I done here? Yes, so BAC. Yeah, this angle here. So that's going to be 180 minus the other two angles. So minus uh, 90 plus x. That's going to be minus 90 minus x. Minus y. That's going to be just 90 minus x minus y. And therefore, then if we consider the small triangle ABO, well, again, that same angle, BAC, all we know 180 is going to be them all added together, right? So it's going to be ABO, no, BAO. So that's going to be, let's redo this all again. Ninety minus x minus y. And then this angle here, which we said was 90 plus y. Which I'm not sure that might be good for us. Plus x. No, that's not good because that's telling us 180 equals 180. Uh, hmm. Ah, these circle theorems. So that's 90, tangent and radius. That's y. That's 90 minus y, I believe, right? 180 minus 90 minus y. That all should be correct, I believe. If that's uh, yeah, A B O B O, yeah. That's BX. And then let this angle here. Yeah, it's on the straight line, right? It's on AOC. Told us it's a straight line. So if that angle's 90 minus y, that has to be 90 plus y. Because you add them up, then you get 180. And therefore that angle is 90. Uh, that angle is going to be 180 minus y minus x minus 90. So it's going to be 90 minus y minus x. But we did that, didn't we? Yeah, 90 minus x minus y. Because if you consider the big triangle, this is ABC. That's x plus 90. That's going to be y. So therefore that should be 180 minus this. That's going to be 90 minus x minus y. Because they all sum to 180. But we also know that these three angles in here have to sum to 180 as well. X plus 90 plus y plus 90 minus x minus. Hmm. Well, I think this is where it might be centre and circumference. So I think this should be 45, shouldn't it? No, sorry, no, this is a half. Ah, yeah, because we're going to want a fraction, aren't we? Yeah, yeah. So we can then invoke center of circumference. So let's draw this again. No, draw this bit. Sorry. Uh, how do I want to draw this? Uh, draw it here. So we know that this is 90 minus x, and this is the center, right? No, that's the center. And the angle it makes here is 90. And the angle this means this should be half of that, so it should be 45 minus the half y. Okay. Uh, so actually, this is going to be, I believe, 45 minus the half y. Uh, as angle circumference at, uh, at, circ- uh, at circumference is half angle the angle at center. Okay. So therefore, yeah, BAC then. So we know that 180 is going to be this. 45 minus a half y. I'll make sure I make that clearer. Half y, so that's angle BAC here. 40 minus a half, 45 minus a half y. And then we add this, so x plus 90 plus y. No, sorry. Yeah, yeah. And then plus x plus 90 plus y. Plus y, and therefore then we have an equation for x and y. Finally, which we can simplify. So get rid of the numbers. So minus 90 minus 45. And that should be 45 then. That's going to be half y because y minus a half is just a half plus x. And actually, therefore, we can say that they want us to express the angle in terms of x. So y has to be in terms of x. So that means a half y is going to be 45 minus x. Therefore, y is going to be 90 minus 2x. And I hope that is right. My God, these beastly circle theorem questions, man. Now, obviously, that might have took me a bit of a while. However, I mean, I've not practiced circle theorem since my GCSE circle theorems, which was, God, like 8 years ago now. Obviously, you should be practicing loads of these type of questions, so it should be second nature. Um, but yeah, that's the sort of process you want to go through. You want to basically think about what circle theorem can I use, apply it, and then work out what angles you can work out, and then see what else you know from that. Yeah, so 90 minus 2x, that's the answer, thank God. Oh, nice. Easier questions for me now. God, geometry, I suck at. But these algebra questions, I love. Anyway, but it's not about what you like, it's more about what you can answer. But anyway, now we're on question 12. We're nearly there, actually. Prove that the square of an odd number is always one more than a multiple of 4. Sound like a waffle there, break it down. Square of an odd number. So we want an odd number, we want to square it. So you should know every odd number we can write in the form 2k plus minus 1. K is just uh, any positive number, positive integer, right? Because notice 2k will always be even because we're doubling it. So then to get it odd, we can just take or add 1 to make sure it's odd. So that's the idea behind that. So then 2k minus 1 squared, because it's a square, we want to see what happens. That's expand that. That's going to be 4k squared minus 2k minus 2k plus 1. But that's going to be 4k squared minus 4k plus 1. It's not evidently clear, but what does it say? It's always 1 more than a multiple of 4. Well, yes, that's true because we can factorise this now. 4k squared minus k plus 1. This is going to be an integer. K squared is an integer. So if you subtract two integers, that's also an integer. And obviously this is going to be an integer. So this is going to be 4 times a number, which means multiple 4. So this is 4 times an integer. Add 1. So therefore, 1 more. So that therefore it has to be 1 more than a multiple 4. There you go. So that's always a step, especially at GCSE. They're pretty much always only gonna require you to do odd numbers and even numbers, and then you'd often probably have to expand, square it or cube it. At GCSE, the algebraic proofs should be pretty easy. It's pretty easy to practice once you see some of them, but it should be second nature by now. With these proofs, always set an odd number to be 2k minus or plus 1, and then an even number to be 2k. Oh, I'm going to be here in a second. Okay, I'm back. Yes, so we left off with the proof. Now we're on the third question. I always expect a third question as well. Always expect an algebraic proof question and a third question. But here we are. So it said this expression here can be written in the form of a simplified third, a root 10. It's bog standard. The value of a. Cool. So obviously, the best thing to do here is to work with this fraction. Fraction. God, this bracket. Um, root 5 of root 8 plus root 18. Now, there were two ways you could approach this. You could expand it first, but then deal with some not nice numbers, or you could try and simplify it before you expand. So, root 5 we can't do anything with. Root 8, actually, we should note root 8 And this is where you need to use the third rule. Root AB is root 8 times root B. So again, we can distribute the third. So if you have a product to multiplication, you can multiply them separately like this. Bring the thirds out. So with that in mind, we know that root 8, well, we know that's root 4 root 2. Root 4 times 2. That's going to be root 4 root 2. And you should know root 4 is 2. So that's going to be 2 root 2. And root 18 is going to be root 9 times 2. And that's going to be root 9 root 2, which should be 3 root 2. So actually, it simplifies quite nicely. 2 root 2. And then we can collect like terms, because root 2 is the same. So, oh God, what am I doing here? Root 5 of 5 root 2. Because for 2 plus 3, root 2 plus 2 is 5 root 2. And so, yeah, so what's happening here is saying it's 5 times root 2 and then times by root 5. Again, you can kind of do the opposite. You can also bring two different thirds into one by doing it together. So 5 times, times root 2 times 5. And that's going to be 5 root 10. So that means A has to be 5 there. Lovely jubbly. A lot of people seem to really panic with surds. They're a bit confused what surds is and feel like it's a mess. Essentially, a surd is just a number that has like a square root or root of the form n. So just any number, but n is not a square number. So this means n if cannot be 1, 4, 9, 16, 25, which because if we square rooted 4, for instance, if n was 4, root 4, that's 2 squared. If you had root 9, that's 3, sorry, that's 2. Because it's 2 squared, that'd be 3, because 3 squared is 9, and vice versa. Basically, a third is any number where n is not a square number. So what's inside the square root is not a square number. Because if you had a number that said like k squared, obviously it kind of cancels out to just k. Because the square is kind of like the inverse of the square root. But if it doesn't have a nice square root, so if n's not a square number, then it's a third. Because root 8 isn't a square number. Root 18 is not a square number. Root 5 is not a square number. So all of these are thirds. So you cannot ever write this in terms of an actual number, whole number, right? It just has to be left as a square root. That's all it is. That's all it is. It's essentially a square root where the number inside is not a square number. So it doesn't cancel to a whole number. That's all it is. And yeah, and that's the basis of it. And obviously, you should also remember this third law: root AB is root A times root B, because that will allow us to then simplify stuff. And also, when you're adding two thirds, they have to have the same third, right? Like here, you have to, if you're going to add 2 root 2 plus 3 root 2, you have to make sure it's the same number here, root 2. If because then we can add it like terms almost. If we set root 2 to be y, then that's the same as saying 2y plus 3y is 5y. So it's exactly the same concept as algebra, right? As collecting like terms here. And that's the idea behind that. So if we had 2 root 2 plus 3 root 5, we can't do anything with that because root 2 and root 5 are different. But because these two are the same third, root 2, the number's same, we can add them like it's like terms. And that's all you need to remember with thirds. What a third is. So the square is not a square number in the square root, and the fact we can split them up by doing split the thirds up like this, and that's it. That's all you need to know with thirds. It's not actually people overcomplicate it more than they should do, and that's all it is essentially. Um, but yeah, I guess if I do like a third video or something like that down the line, yeah, that's basically how to explain it. And yeah, that's thirds. Nice remark. Expect a thirds question. Absolutely. Might not be in the first paper, but it'll definitely be in the in one of them anyway. So then it says y is inversely proportional to d squared. When d is 10, y is 4, d is directly proportional to squared. Da, 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 da. So it's a proportion question. So there's two types you need to know. Direct proportion. So this is of the form y is kx. But k is just a constant. Sometimes people call it the constant proportionality. It's just a constant. So when you vary x, y varies with this equation. So it's just basically when you see direct proportion. So for example, d is directly proportional to x squared. This means that simply d is kx squared. Okay, and the other one is inverse proportion. And this is instead saying y is k over x. So it's like 1 over x times k. So one's like a reciprocal almost, kind of like inverse. You know how like we did before the third. So you had like not the third when we did the index law question, 27 like -1, like almost like the inverse, and that's just reciprocal, like the fraction. That's not strictly true, but that's kind of one way of knowing it, I guess. Because the idea is with direct proportion, what that's saying is when you change one variable, x, y changes directly in the same way. So, say, for example, if x increases here, y also increases in the same way. So it increases and y increases linearly. So as x increases, y increases directly. And inverse proportion, it's the opposite way around. So as one variable increases, the other variable decreases. So this looks like the graph 1 over x, right? And this looks like the graph y equals x. Notice k, it looks like a straight line here. And this looks like a reciprocal. Because as x increases here, y decreases, right? But as y increases up here, y goes up, x goes down back to 0, so x gets smaller. So direct proportion essentially is as one variable increases, the other increases, and vice versa. If one decreases, the other decreases. So it's directly linked. Uh, but with inverse, no, it goes the other way. So if one variable increases, the other decreases, and vice versa. That is the whole idea behind inverse and direct proportion. And actually, again, people I feel overcomplicate this. So use like this weird symbol here. Uh, that just means proportional. That's all it means. But actually, these are what the equations you should get. Okay, so direct proportion was kx, inverse was k over x. That's all you need to know. No symbols, no nothing. That's all you need to know. And that k is obviously a constant here. So then, yeah, so that means that's a d is kx squared because d is directly proportional to x squared. Likewise, y is inversely proportional to d squared, which means y is a different letter. So the constants will differ. So let's call this p over d squared. Uh, Make sure not use the same letter because it's not the same constant here. two different relationships there, so two different constants. And yeah, so but the information we're given, essentially, we substitute to find these constants in. So we're given d is 10, y is 4, which means here, we substitute it in. 4 is p over 10 squared. Oh, which is 100, right? Which means p, if you times across, is going to be 400. And you can check this because 400 over 100 is 4. Likewise, x is 2, d is 24. Which then means it's substituted to here, 24 is going to be k of 2 squared, which is 4k. Therefore, k is going to be 24 over 4, which is 6. So therefore, then it's asking y in terms of x. Well, then let's rewrite these two again, because now we know the values of the constants. So d now is 6x squared. And we also know that y is 400 over d squared. Well, actually, if we just square d, we get d squared. So that's going to be 6x squared squared. So that's going to be 36x to the 4. And so therefore y is simply going to be 400 over 36x to the 4. Now, it's set as simplest form, so the fraction needs to be simplified. So we need to simplify 400 over 36. Again, notice the fact it's even, so this cancels down to 18 over 200. And again, they're both even again, so that's going to be 9 over 100. That doesn't simplify anymore. 9, only 3 and 1, and obviously 9 goes into it. 3 doesn't go into this. So it's simplest. So this is the simplest form of this. So it's going to be 100 over 9x to the 4. Okay, so that should be the simplest form. There we go. Let's double check this. Lovely, yeah, that's the answer. Okay, some more algebra. Okay. Factorize a squared. So this is just, you need to know this, recognize it. This is the difference of two squares. A and B are squared here. So this is simply going to be a plus b, a minus b. If you expand it, you'll get this back. So just double check your answer. But that you need to recognize it's the difference of two squares. But yeah, I don't. Is there anything else I can say about this? I don't know, but that's you need to recognise the difference between squares. Then it says hence or otherwise, simplify fully. Key exam tip: if it says hence, that's saying you need to use your part A answer, and this is going to help. So notice it's vaguely a similar form. We have another square number here, A, minus another square number here. So these two brackets are squared. So I think if we let A be x squared plus 4, so if we let b be x squared minus 2, I think it would look like a squared minus b squared is this, right? Square, where this fraction here, this bracket, sorry, is a, which is squared. And then therefore we can use the same result. And that's going to be a minus b, a plus b, which is then going to just simply be x squared plus 4 minus b, which is minus x squared, minus minus 2, which goes to plus 2, and then a plus b. So it's going to be x squared plus 4 plus x squared minus 2. And therefore, there we can simplify what's in each bracket. X squared minus x squared goes away. 4 plus 2 goes to 6. And then x squared plus x squared, that's 2x squared. Plus 4 minus 2, that goes to 2. So plus 2. And therefore, it's just 6 lots of 2x squared plus 2, which then just goes to 12x squared plus 12. Okay, and that should be your answer here. You could factorize, I guess, if you wanted to 12 x squared plus 1. That's up to you. I don't think. Yeah, the mark scheme, it says either way. That's fine. But yeah, that's how you'd approach that. Read, study, and should be able to make a link with part A here. Okay. Uh, okay, we've got a probability question next. There are only red counters, but they love these counter questions, by the way. We've got 3 different counters here: red, blue, and purple. The ratio of red to blue is 3 to 17. Sam takes a random counter from the bag. The probability it's purple is 0.2. Okay, work out the probability Sam takes a red counter. Now, if we want a probability, we need how many red counters there are over how many counters there are in total. That's going to be the key here. Okay, well, we know if the probability counters purple is 0.2, the probability it's red or blue is going to be 0.8, right? Because the total probability has to be 1. So that's going to be 0.8, which means this total here has to be 0.8, this ratio here. Again, you could scale it to say, like we did in the other question. If we can say 3x plus 17x is going to be 0.8. Yeah, actually, that's what you want to do, right? Yeah. What did I say? 3 plus 17 is 0.8. Obviously, that's not true. So yeah, so make sure this is the ratio, but to get the actual amount of red counters to blue counters, you want to include an X, but obviously that's the total. Hang on, this ain't gonna work very well. But this is a probability, so we want the probability of blue or red out of how many there are in total. So that's going to be 3x plus, well, that's just going to be 20x plus p, and that's going to be 0.8. So if we simplify this, that's going to be 20x. Where p is how many purple counters there are, but we know how many purple. No, we don't actually. Purple would be 0.2p over the total here. No, there's got to be a better way of working this out here. No, it can't be this, can it? No, never mind. Yeah, so stick with this. 0.8. Okay, the ratio of red to blue counters is 3 to 17. Right, okay. So what that's telling you is, if we add this together, that that's going to be 20x, right? Uh, the probability of picking a red or blue counter here, that's going to be 0.8. 8, but that's not the probability, is it? That's how many blue and red counters there are over how many total counters there are. T for total. Okay, so that means 20x is 0.82. Okay. So we can express the total counters in terms of how many blue or red counters there are. So I should probably say let x equal number, the scale factor, I guess. Basically, x is the scale factor for how the ratio to the amount that you count there are. Anyway, so that means 0.8t, which is also 4/5. So therefore, t, this might not get me anywhere, but it's good to work with what you know. T is going to be 5/4, so it's going to be 5/4, 20x. That's going to be, well, 20 cancelled with the 4 to give you 5. And then 5 times 5 is then 25x. So that's the total. Okay, so then it says the probability. So if the probability that is red, so it's going to be how many red counters over total counters. But actually, we know red counters. We know red counters is 3x, right? And we also know total is 25x. So actually, P that is red, the probability it's red, is 3x over 25x, which cancels to 3 over 25. I think that should be the probability here. Uh, is that right? Yeah, 0.12. It gives you, yeah, that's the answer. But weirdly, the mark scheme gives it in terms of a decimal. But the decimal equivalent is 0.12 here, which is the answer. But that's how to approach it. Don't be afraid to use variables to represent unknowns. Like, if I don't know the total here, just call it T, and then you see what you can work with. If you don't know what the total amount of counters is, just scale it by times it by x, and then add it. And yeah, that's that question sorted. But if there is a simplified way of doing this, let me know. But that's how I would approach it. But I'm a bit more like rigid and algebraic, so I don't know. But anyway, there we go. Now on question 17. Simplify, again, a very common exam question. Simplify an algebraic fraction. With this, it should be on autopilot by now. Always, always, always try to factorize. So let's factorize the top. 3x squared minus 8x minus 3. Now, actually, it's quite awkward because you have a 3 in the front. So we're going to need to factorize a bit more carefully. So there's a method with this is to firstly times 3 by the constant here, minus 3 minus 9. And then think about, and then consider the expression 3x squared minus 8 minus 9. And then basically treat this as a normal quadratic in a way. So minus 9. So we want something that adds to minus 9. No, adds to minus 8, sorry. And times to minus 9. But the obvious one is going to be minus 9 and 1. And yeah, so what we can do then is 3x squared, and then we want to, and then times this by x. So, and this is going to be minus 9x plus 1, and then you want to bring the minus 3 in. No, plus x, sorry. Oh, minus 3, and then bring the minus 3 back in. It's a really weird method. But again, just for the part, I'm not going to probably go too much into the derivation of it, but that's the method. Obviously, I imagine people have their own, but I think that's a really common one. It's one I learned in school. So the idea is times it by times a constant by a. That's the adjusted quadratic. Then kind of treat it like normal. Then you do the time, work out the pairs that add and times, and then bring it back into there. So basically, you're finding a substitution for the minus 8x here. That's all you're doing here. See how we split it up into minus 9x and x. That's all this method is doing here. But anyway, once we've done this, it should be easy to factorize because notice how you should when you do it this way, you should always have two terms which are common. So factorize the first part, which should be 3x of x minus 3. And then this is simply x minus 3 with a 1. So then that's obviously x minus 3 is common here. So it's kind of like saying, I don't know, 2t plus 5t. Obviously the t is common to both, so 2 plus 5, which is 7t, which we know is 7t, we just add them. That's the same sort of step that's going on here, just to clarify. So x minus 3 is common and 3x here from here, and then add, and then there's this little 1 here. And that is the simplified quadratic. Likewise, 2x squared minus 6x. Again, a 2x is common to both. So it's going to be x minus 3, and that's your simplified version. So therefore, the fraction, if you bring this all in now, it's going to be x minus 3, 3x plus 1 over 2x, x minus 3. Notice that these cancel now, so you're left with simply 3x plus 1 over 2x. That can't be simplified any further, so we leave it there, and that should be your answer. Okay, we're on this question now. Here's a graph for y sine x. They're quite nice to give you the graph for it, I'm not going to lie. All it's asking us to do is to shift it. So, sketch the graph of sine x minus 2. Now, for any graph, y is f of x. So here f of x is sine x. If you're doing f of x minus 2 or plus a constant, you're shifting graph down by 2 units. So down being down on the y-axis. Because what you're doing is f of x, that's your y value, right? But then if you're subtracting 2, you're subtracting the y values by 2, essentially. So the y values go down, so the graph shifts down by 2. That's all that's doing. So that's all you're doing. So essentially, plot shift the graph down by minus 2. So think about the key points here. That will go down to minus 2. That will go down to minus 3, which is here, minus 3. Minus 1 to minus 3, 0 to minus 2. 1 to minus 1, and then 0 to minus 2. And then keep the graph shape the same. So it's a sine curve, which I try my best to draw, but oh god. Oh, it's really rubbish that is. Let's try it again. Something like that, although don't make it look like a line, but I don't know. Something like that. Okay. Actually, should be careful there. That's not. See that it's dipped a little bit there, so that's not an accurate shape. I want to make sure it accurate. Oh God, it it clearly dips here and then goes up. For God's sake, there you go. Then it rises up, reaches the top there, and then goes down. I'm gonna make it the graph. I don't know, as kind of look as reminiscent of the original one as possible. There you go, something like that. Then obviously it's a bit wonky there, but obviously use a rubber there, rule it out, then connect it. It's a bit awkward on the drawing graph paper. I'd be able to do it better in real life on paper. But anyway, that's what you do. You're just shifting it down by -2, the y values, so the curve shifts down. And that's all it asks you to do for 2 marks. Pretty nice actually. Okay, we're on this question now. Yeah, as you'll notice, the later part of the paper seems to be a lot of grindy, some a bit more advanced algebra. Personally, I love that stuff. But see, I find the early parts of the paper easy, harder, and I'm blitzing through it. But anyway, everyone's different. So now we have a coordinate question. So P is this coordinate, Q is this coordinate. A line perpendicular to PQ. So let's sketch this. So if, let's say this is PQ. Doesn't really matter where exactly they are. A rough sketch to show what's going on. A line perpendicular to PQ has the equation to 3x. So bear in mind, perpendicular means intersect at right angles, right? Meet at right angle. So if two lines are perpendicular, they meet at a right angle. What that also means as a result is gradients are negative reciprocals to each other. That should be something you should be familiar with. But anyway, a right angle. So this line would look like this, and it would have a right angle there. And that's this line here, perpendicular. So this is line PQ, and this is the perpendicular line. And this has the equation 3x plus 2y is 7. Okay, so let's think about what we know. We know it intersects. Okay, first of all, we know the line PQ has the equation. Always with this, always give the general equation. Y is mx plus c. Line PQ has this. So essentially, what this boils down to is finding the gradient m and the y-intercept c, and then we can do some stuff with this. Okay, so we know. Uh, But we can rearrange this. So we know that this equation is 2y is minus 3x plus 7. Therefore, y is minus 3 over 2x plus 7 over 2. We know that the gradient m has got to be 2 over 3 as PQ perpendicular to the line, right? To this line here. So obviously 2/3 times minus 3 over 2 equals -1. That's what you want. So it's a negative reciprocals. If you times the two gradients together, you always get -1. And that's how you can check you've done it right. Yes, so that's m. So y is 2/3 x plus c. This might not help us. We never know, but we can work with it anyway. But now we have a point on there, right? We have p. We know that p, so we can substitute this into the line here to find c. Sub p, which is 3, 4, I believe, into pq, into the equation of pq. Okay, so that means 4, it's going to be 2/3 of 3 plus c. Well, actually, that simplifies to just 2, doesn't it? So 4 is 2 plus c, which means that c has to be 2 for that to happen. So therefore, how do I want to write this? Therefore, y is 2/3 x plus 2. So we have an equation for PQ. Now, well, actually, we can find an expression for B in terms of A because we can just substitute the Q coordinate in, right? Because Q is AB, right? Is it? Yes. Substitute that coordinate into PQ, and therefore y is now B. So B is going to be 2/3 A for x plus 2. Yeah, and find an expression for B in terms of A. So B has to be in terms of A. So B has to be on the left hand side equals some lots of A. And that should be your answer there. Lovely jubbly. Oh, and the final question now. Here we go. Okay, n is an integer such that 3n plus 2 is less than 14, and this is very common for the last question. I've seen this on a few past papers. Obviously, a quadratic inequality or inequality. There's two lots of them, and you have to do them separately. So that's what we're going to do. So if it says and, we have to solve both of them. So first, we're going to solve plus 2 is less than or equal to 14. That's just a linear one. So we know that if we treat this like a normal equation, minus 2, that's 12. Therefore, n is going to be 4, right? 12 divided by 3. That's one solution. Now we're going to look to solve the second one, which is a lot more complicated. 6n over n squared plus 5 is greater than 1. Okay, so with inequalities, you have to obviously be careful uh, when you deal with negative. If you times by a negative or divide, vice versa, if you multiply either side of an equality by negative, you flip the inequality. However, that's what you need to be careful with. But notice n squared plus 5 is positive. Because obviously n squared is always going to be above 0. Adding 5 makes sure it still remains positive. So if we get rid of this fraction by timesing by n squared plus 5, we can just times through and it will preserve the sign in the inequality because it's positive. And so now at this point, it's just a very bog standard quadratic inequality question. If we then subtract 6n, it would have 0 is greater than n squared minus 6n plus 5. And actually, we can just reverse it. So we can then say n squared minus 6n plus 5 has to be less than 0. Yeah, now this is the quadratic. Now, with quadratic inequalities, once you got it in this, I'll find the critical values first. Let's check, can we factorize? So we need two numbers that add to give 5 and add to give minus 6, sorry. And times to give 5. What numbers do we have? That's obviously 5 here. 5 and 1. Well, yes, because if you can treat it as minus 5 and minus 1. So it's going to be n plus 5. Oh, hang on. Second. So if we have minus 5 and minus 1, add them minus 6, times them, it'll still be 5 because times two minus numbers, you get a positive. Which means we can factorize, right? So I believe should be n minus 5, n minus 1, less than 0. Check this. it can expand quickly. N squared minus n minus 5n gets you minus 6 times, and you get 5. Cool. Which means the critical values are, you don't have to write critical values, but I'm just going to show clearly, are n equals 1, n equals 5. Now this helps us to draw the quadratic here, because what the idea is, we're going to spot where the region, the graph goes below the y-axis. You'll see this in a minute. Okay, so let's draw a little sketch of the graph here. So let's we're going to have where n is 1, n is 5. Now it's a positive shape. It's going to look like this because the coefficient on the n squared is positive, is 1. So it's going to look like that. So and it's going to pass through 5. So it's going to have a shape that not exactly. That's rubbish. There we go. Oh god, it got rid of the axis. So it's going to look like that, although it's a bit wonky. So obviously that's 1 and that's 5 here. And that's 1 where it passes through. Now pay attention to this. If we say y is n squared minus 6n plus 5, this is same as saying y is less than 0. So the y-axis, the graph, has to be below 0. Obviously, it goes below 0 here. This is the region we're interested in. And when it's strictly below 0, it's going to be when n is strictly between 1, sorry, not minus 1, 1, n and 5. If we include equals to, then it includes like the points of intersection here, but it's strictly less than. If it's equal to 0, then it can be 1 or 5. But if we want it to be strictly less than 0 below the x-axis, it has to be in this region here, which is clearly between 1 and 5. This is why sketching the graph is just absolutely essential. This quadratic inequalities like this. So yeah, so now actually we can piece it together. So we can say we've got two solutions almost. So n is less than 4, and we also have 1 is less than n less than 5. We can piece this together now. So think about it. We need it to be as strict as possible. It includes both of them. So if n has to be above 1 and has to be less than 5, but this also has to be less than or equal to 4. So actually we can rewrite this as 1 less than n less than or equal to 4. Right? Because obviously if it's less than or equal to 4, then it's clearly going to be less than 5. So we need to tighten it, make it strict. So combine them together. If it helps as well, draw a number line. So if this is 0, where's the key points? 1, 4, and 5. Obviously, the first one has to be between 1 and 5. But also, it's saying n has to be less than or equal to 4. Now, you want this region here, right? Which is going to be between 1 and 4. To include both the inequalities here. So between 1 and 4. And that's where this comes from. Just think about the value here, because it's and it has to satisfy both of these inequalities, so you have to combine them together. Okay, but that's not the final answer, because pay attention to this detail here. N is an integer, which means n has to be 1, 2, 3, 4, 5, 6, da 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 da. So whole numbers, right? Now, what whole numbers are strictly between 1 and 4 and equal to 4? Well, it can't be, n can't be 1 because it has to be strictly above 1. 1 has to be strictly less than n. So n cannot be 1. It can be 2 because 2 is between here. So n can be 2. N can also be 3. That's still between 1 and 4. But also it can be 4 because it's less than or equal to 4. So 4 is less than or equal to 4. And obviously anything outside of this is not accepted. If it's 5 or higher, that falls out of the range. If it's less than 1, that also falls out. So this is our final solution here. The integer values are 2, 3, and 4. And that is going to be your answer to this. And that is a strategy with dealing with these final questions with inequalities when there's multiple of them. You solve each inequality individually, like usual, but then combine them at the end to make sure they all satisfy each other. Use a number line if that helps. But yeah, that's how you approach that. And actually, we're at the end of the paper now. But yeah, obviously, I did check some of the questions. We did have some hiccups, but we got there in the end. But that's generally how I'd approach it. Yeah, obviously, I haven't done circumference in ages. I remember that being one of my weaker topics as well when I was in school. Uh, but yeah, we got through that in the end. I tell you what, though, that one question about the profit. Let's go back to that. That still stumped me. I have never heard profit in terms of the cost. Normally, it's um normally oh, also this one as well. Yeah, we forgot to include at first anyway. Forgot to start from A. So we forgot to add the initial coordinates, but yeah, we got through that in the end. Uh, Obviously a little hiccup there, but yeah, that was silly. uh, so this one was fine, I believe. This one, the profit one. Profit, right, percent profit. I thought it was a rate. Well, if you use the margin, like the percentage profit you make, you take that as a total of the amount you gain, the total sales, the revenue. I've never seen it as a fraction of the cost. So the percentage profit, apparently, then is profit over cost or total cost as well, not the revenue. Now that stumped me. I thought it was all that. Pretty sure it is. I've looked it up, but I don't know. Edexcel clearly went a different way. And yeah, that's the whole paper. Yeah, obviously it took longer than usual. A, I'm a bit rusty, but B, I was mainly explaining things, and obviously it can take longer. Obviously you have an hour and 30 minutes or extra time. But yeah, that's one of the papers. That's just a paper, 2018 paper, paper one. But obviously, yeah, on the run up to obviously the exam next this week on Thursday, I believe. We just do paper ones to test your non-calculator skills. Um, but yeah, overall, I won't say it's a bad paper. I mean, there's no obviously in recent years there's like the monster circle questions, like you've seen them go online. They're that horrible. They're trending. But yeah, I don't think the papers are that bad. I mean, I don't know. This one anyway, but that's just a walkthrough of a paper. I don't think that's what most paper ones would look like. Also, I should probably say two questions to always expect. Although on this paper didn't have any of them. Always expect an arithmetic question. Um, so this is something like 0.28 times 67. So you're going to need to use line multiplication or division. And two, expect to use exact trig values. This didn't assess it though. So you're going to need to know stuff like sine of 60, cos 45, oh, tan 30, and so on. You need to know your 0, 30, 45, 60, 90-degree ratios of all sine, cos, and tan. That should I would expect that to come up. I really will. Um, and also probably I'd also probably expect standard form calculations to come up because on the calculator it's fairly easy to work it out, whereas non-calculator obviously that's where it really tests you because you can't use a calculator to like because obviously the calculator gives answers in standard form and stuff like that. So Those are the three questions I'd expect, and obviously fractions as well. But there's some topics which will come up every single year, even every single paper. Uh, like for example, fractions plus ratio plus probability will come up on every single paper. I pretty much guarantee it. Um, always come up on every single paper. Always. So there's some key topics to revise there. Um, but yeah, I'm gonna leave that there then. I did start streaming earlier. I don't know if I'll come on a bit later. I won't do a paper, another one. I am also scheduled to be on tomorrow. I'll do another past paper, unless someone requests something different. But I might come on later. I might do a separate stream. I might go over a few topics. Not necessarily past paper, but a few topics. And I'm also just before I leave you, I'll recommend this website. Oh, I don't have the website open, but it's here. And it's Math Genie. I think this website is a legend and a lifesaver for maths GCSE. Let it load. And yeah, you go into GC revision. It does every single topic possible, split by exams very clearly, by grades and stuff. And it gives you videos to explain it. I think the videos are very good. I think they get straight to the point. They give you an example question, the guy does. And then it goes through it. The exam questions, literal questions from Edexcel about the topic and solutions, and even written answers to explain it as well. I think this website's absolutely fantastic, and it's free as well. So I know a lot of stuff like Hegarty Maths and Maths Watch. Obviously, you have to pay for. Your school has to do it. This one completely free, and I think it's very very good. Personally, I don't think I would have got a 9 without without this website. This website's goated. It really is. But yeah, that's just a recommendation. But as for this, I'm going to leave it here for now. So yes,